In this section, we're going to be talking about dividing polynomials. So we've done addition, we did subtraction, we've multiplied them, so now we have to learn to divide them. Now there are two different situations whenever we divide polynomials. You're either dividing by a monomial, which is one term, or you're dividing by something other than a monomial, any other polynomial. Okay, division by monomial is what we're going to do first, and it's actually the easiest of the two, although neither one of them are that bad once you get the pattern down. But before we start actually covering that, I want to go back to fractions, and I want us to talk about how we add and subtract fractions, just so you'll be able to see something whenever we start in with this division. If we were going to add something like this, the 3/5 plus 1/5, well, hopefully, automatically in your head you see 4/5. But let's think about how and why. In order to add fractions, we have to have the same denominator, right? That bottom number has to be the exact same. Well, in this case it is. So we have a common denominator. Now our next thing is, once you have a common denominator, you just simply work with the numerators, adding them or subtracting them. That's where we would get the 4/5. But think about what's really happening. You're really saying, now let's add that numerator, 3 plus 1/5, which then would be 4/5. But if you can go forwards, you should be able to go backwards also. So if we started out with something that looked like this, we should be able to pull it apart into separate terms and it mean the exact same thing. If you can put them together, then you should be able to pull them apart and they should mean the same. This is the idea that we're going to use in order to work with our polynomials. So let me pull up that problem. First one here. This one says we have 12x to the 4th plus 3x squared all over x. Now what I'm going to do before anything else is I'm going to separate this because I am dividing by a monomial, one term. So if I were to rewrite this as 12x to the 4th over x plus 3x squared over x, that would mean the exact same thing. These are equivalent expressions. Now because we separated this, now we can go ahead and use our exponent rules and just the things that we know about fractions in general. Exponent rules say that we would take, if we're dividing like bases, that we would subtract the exponents. So that would be 4 minus an understood 1 would be a 3. So this is 12x cubed. Now another way you could look at that would be to say that this x will cancel into one of these and leave 3 on top. Now over here we have 3x squared over x. So again, you can think about it as this x cancels into one of those and just leaves us with an x on top. So that would be plus 3x. That is the answer when you do this division. All right, let's look at one that looks a little bit larger. Here we have 8x cubed minus 4x squared plus 6x plus 2 all over 2. So the first thing I'm going to do is recopy this, writing each and every term over that denominator of 2. And if you'll notice, I'm putting plus on each one of these. And then the one that had the negative, I put that at the top. Now we can simplify. 2 goes into 8 4 times, so that would be 4x cubed. 2 goes into negative 4, negative 2 times, so that would be minus 2x squared. And 2 goes into 6 3 times, so that would be plus 3x. And 2 over 2 is 1. So this is the answer when we would do that division.